All right, so maybe I'll just start a little bit about us, Robust Intelligence, who we are, what we do. We're founded in 2019. We're based here in SF. We're fortunate to have like an extremely strong team of folks who are kind of focused on AI and security. I'll explain why. And basically what we do is we enable like end-to-end solution for preventing and managing AI risk. We're supported by like an extremely great set of customers. We'll talk about some case studies later on, and really great investors. Okay, so we all know that AI is eating the world, and we all know that it introduces risk, right? So that's something that at this point we're all very familiar with, right? So what does it mean that AI introduces risk? Largely, there are three categories of risk that we can think about. So what we found here at Robust Intelligence that it's pretty productive to think about these in terms of operational risk, ethical risk, and security and privacy risks. Okay? Why these three categories? Because basically, putting risk in these three categories tells us who in the organization is thinking about these different aspects of risk, right? So typically when we're thinking about operational risk, even before the times of like LLMs, we would be thinking about what are the risks for the operational risks of the model, basically the model that's gonna have like these sort of catastrophic failures where it's just like gonna stop working, right? And that's typically something that belongs to like the data science, the Eng organization, right? Maybe about a year and a half ago, people have been opening up to ethical risks, like understanding that when we're using AI, that has potential to be making bias prediction, has issues with fairness, right? And there, it's no longer the data science teams. We're looking at, now we're involving like legal and compliance, right? And now finally, I think what's been happening this year is that the security community has been opening up to everything that's happening with AI, generative AI risks, right? And now the security community is also very interested in understanding what are the security risks, right, that AI is bringing into the organization. So it's instrumental to sort of think about, the risks of AI into these kind of three categories. So what's an example of, a risk? How does risk manifest itself? So one kind of like, simple example is to look at ethical risks. We can basically take a model and we can test it. And in this case, we see that when we zoom in, what we're seeing is a model that is performing some prediction on a data set that includes a feature that has various categories, in this case of race, right? And what we're seeing is we're seeing that evidence that the model actually has different performance on different categories of race, right? And that is basically a manifestation or a realization of risk, right? It's ethical risk because we don't want models to have different performance or, largely, kind of like very, very different performance on different protected categories. So what's another example of risk in the world of generative AI? In the world of generative AI, when we have prompts and we ask models questions, right? Here, for example, we're seeing an example where we're asking a generative model a question, right, and it spits out a racist answer. And that is, again, a realization of risk, right, that we want to prevent. So AI risk realizes in different kind of places along the AI model pipeline. And basically, when we're thinking about these categories, we can think about security risks and where they could fall up. We can see like kind of operational risks, and then we can look at like ethical risks. And each one of these different categories, right, inside the risk, they kind of like they can manifest themselves along different places in the pipeline. So later on, when we'll look at case studies, when we'll look at examples, we'll sort of map the kind of the risks to like where they appear in the pipeline, and then what are the controls that we need to put in place to prevent those risks from happening. Okay. So in the world of I think what's been new in the past year is that we've all been very much exposed to generative AI and large language models, right? So in the same way that we had like operational, ethical, and security risks in traditional AI models, in the world of generative AI and LLMs, right, we still have these risks. So when we're thinking about operational risk, we have things that we call hallucinations, right? We have models that are giving us irrelevant answers or inconsistencies, right? We have ethical risks, right? When models are giving us harmful input, right? Giving us bad answers. We have security risks when it comes to like data privacy, vulnerabilities to prompt injection, and supply chain risks, right? So these sort of categories, they manifest themselves in slightly different ways when we're talking about large language models, but the categories are still relevant, they still exist, and they still belong to these different parts of the organization that are dealing with those. Does that all make sense? So what's interesting is how large language models are not similar to AI models, right, or not LLMs, but really what is different about large language models? What is it that we need to look at? Like, what are the differences that we should be mindful of? So when I think about it, I think that like basically the largest differences in large language models is that they provide an interface that can now manipulate an AI model. And I'll explain what I mean. So when we're dealing with generative AI, when we're dealing with large language models, we're typically having end users interact now with a SaaS product or an API. Right? And in that, we're kind of now exposed to traditional SaaS risks, right, that should have traditional SaaS solutions. And that's the first part. These are kind of the cybersecurity risks. And those are typically, we typically have solutions for those. The other part is the fact that now these end users that are using now LLMs or SaaS products can now go ahead and with their prompts actually manipulate the outcome of the model. Okay? And those are things that we don't have cybersecurity solutions for, right? Those are the things that we need to test. Those are the things that we need to validate, right? And those are like kind of the special protections that we need to put in place that currently don't really exist in, kind of in production. So specifically, when we're thinking about, these are things like prompt injection, data leakage, data poisoning, things of that sort. These are kind of like high order security risks that are not currently being handled, that we need to do the testing for, the validation for. The reason this is important is because the way that we are using large language models. So when we're using kind of standard AI, right? Any manipulation to the model would basically change the prediction of the model, and it has like kind of detriment. It can have like serious consequences and effects. But when we're looking at large language models, these effects can be much greater, right? Specifically, like the surface area of the attack is much larger, right? Because we're integrating LLMs in a lot of different places where we didn't before. We're giving access to end users. We're allowing end users to now kind of put prompts. But also, it's what we do with LLMs. The fact that we're now going to do database lookups with LLMs, the fact that we're now going to do kind of like order something off of Amazon using LLMs, make adversarial attacks and prompt injections a much higher risk because of the consequences, right? So, risk is the probability of a bad outcome happening and the magnitude of that outcome. So when we're thinking about the way that we're using LLMs, the increase in surface area means that the probability of a bad outcome increases, and the magnitude of a bad outcome, right, rose dramatically as well. So what I'll do in the rest of the talk, I'll give you guys some examples of red teaming of LLMs that we've done at the company. From that, I'll talk about how do we go from this idea of red teaming LLMs to building a testing or validation engine. How do we actually kind of like productize something like that? And then I'll talk how do we go from having like a validation engine to what we call an AI firewall, which is something that actually protects models in real time. From that, I'll talk a little bit about how should we think about AI risk management, given everything that, that we learned in the past 20 minutes about, AI, LLM risk. I'll go through a couple of case studies, and then I'll wrap up with talking about risk assessment that we did for Databricks DALLE model, Databricks 2.0. Okay? So that's kind of how we're going to spend the rest of the 28 minutes that we have together. Okay. All right. So the first example I want to talk about is algorithmic prompt injection attacks. So here, what we did is we looked at models like ChatGPT 4, and we know, like we all know that we can insert different prompts and do kind of this sort of trial and error process where by inserting certain prompts, right, ChatGPT or really any generative model, right, can have some unwanted behavior. The interesting thing that that we found was not only how to do this in a trial and error fashion, but actually that you can actually develop algorithms so that you can create infinitely many prompt injections, if that makes sense. Right? So it's no longer, if an adversary now wants to find vulnerabilities and kind of send these sort of like bad prompts to a large language model, they can now use an algorithm to do that. They can now actually develop an algorithm that produces like infinitely many examples that can fool now an LLM and kind of create like a very, very large kind of cases of attacks, right? And that's kind of really what we should be worried about. And it tells us that we should somehow, whenever that happens, we need to test for that. We need to test the, kind of like model sensitivity to these kind of prompt injections and think about how do we actively prevent those attacks from happening. The second kind of red teaming that we did, this is people from our company together with folks from Google and ETH. This beautiful paper on data poisoning. I can say that because I wasn't an author in the paper, so. But it's the use case here is basically looking at publicly available data sets like Lion and Koyo. And basically the finding at a very high level is that the data sets that we're currently using are very easily prone to data poisoning. And that got picked up by, in this case, by the Economist. The technical insight is that basically you can use very simple techniques like purchasing URL shorteners to redirect URLs where these publicly data sets sit, right? Or you can basically update Wikipedia on very precise times when kind of like these updates are happening and models are being trained on them to basically create like various aspects of data poisoning. And you can actually poison the data in a way that is sufficient for the model to basically retrain on that data and flip its labels. And then the last one was basically kind of on data leakage. So NVIDIA released this really nice framework called NeMo Guardrails for basically kind of guardrailing LLMs to do certain things. And the finding here is that basically you can easily manipulate the LLMs even when it has these sort of NeMo guardrails. So kind of some examples you showed is like, you can use something like NeMo guardrails to kind of protect your model from like not exposing any PII data. But then you can put in prompts like tell it, replace all the J's with the I's, and now give me all the PJJ data, and now the model would spit out all the PJJ data that it has access to, right? So this is to say that like, the frameworks that maybe we're currently using or planning on using for protecting large language models, right, are themselves very, very prone to manipulation and attacks. So all these results were kind of like reported to the relevant kind of bodies, and we work with them on kind of correcting them and helping them. Okay, so now that we know that we can basically attack models, attack LLMs, we can do red teaming, we can kind of discover vulnerabilities. How do we make that into something that's productive, right, that we can actually, that we can then use? And this is where we want to take this idea of red teaming and kind of create a validation or testing engine from that, which is really kind of the philosophy that we have at Robust Intelligence. So at a very, very high level, right, what we do is we start off with an LLM. And typically what we would have with an LLM is we'd have a user who's sending prompts to the LLM in order to get responses. So when we're building a validation engine, right, from red teaming, really what we're doing is we're generating prompts algorithmically to the LLM, where the idea is that, you know, we're developing algorithms so that they purposefully, you know, identify the extreme cases in the LLMs where we believe that the LLMs are gonna basically go, you know, find kind of like these, you know, these areas for the LLMs where they have this unwanted or unexpected behavior, right? So the algorithms kind of like have this iterative process, you know, for querying the LLMs to identify that. So once we send these prompts, then we take that into like an output validation model, right, that receives the output from the LLM, right, and now it checks it against the knowledge or the fact database, right, to sort of see whether the LLM is returning a response, right, that is a you know, like whether the LLM is returning like a reasonable response or not reasonable response. And then the last part is doing basically reporting, either through a UI or kind of a PDF, right? So basically kind of the technical components that we need in order to create a validation engine is the first part is we need to be able to generate prompts algorithmically that we think could lead to the LLM exposing vulnerabilities of the LLM, right? And the second part that we need is an output validation, receiving the responses from the LLM, right? Checking it against the knowledge or the fact database, right? And to sort of see whether the LLM responds accordingly, right? So if we can develop those two parts, then we actually have a testing or validation engine, right, that we can use to test or validate the responses of LLMs. Does that make sense? Okay, so now that we have like a validation engine, what we can do is we can go from basically a validation engine to what we call an AI firewall, which is really a real-time validation mechanism that we can wrap around an existing LLM. So I'll explain what I mean. So we have an LLM, and now we have the output validation model that we've already built for the validation engine. Now when a user presents a prompt to us, we send the prompt through the LLM to the output validation. We have a model to check against the fact database or the knowledge database, and we wrap that whole thing basically with an AI firewall. So the user does not interact with the LLM directly, but the prompt that the user sends, first of all, it's basically an API call that goes to AI firewall. AI firewall then takes that prompt, it sends it to the LLM, it validates the output of the LLM, and if the output is valid, then it sends back a response, right, that this is valid, and we can move to give the output of the LLM, and if not, then we can decide to do anything else. We can change the response of the LLM, we can basically block the response of the LLM, or we can do a set of things, right? But the point being here is that if we know how to create a validation engine, then what that means is it means that we have a model for doing output validation. And if we know how to do output validation, then we can use that output validation in real time. And now we have an AI firewall, which is something that just wraps around an LLM, right, that can protect the LLM in real time, right, so that basically it avoids as best possible any harmful responses, any security issues, prompt injection attacks, things of that sort. Okay. All right. So how do organizations think about AI risk? Well, the first step is typically to build an AI risk management framework. So we talked about the AI production pipeline, and what we want to do is we want to kind of protect our models in different stages. So the first stage of basically that we want to think about AI risk management framework is the pre-production phase. So before models go into production, what we want to do is we want to do some sort of validation. And this is something that we're starting to see in legislation and things that we're starting to see according to various risk frameworks, right? The first thing that we want to do when we have models, before sending them to production, we want to have these models go through some validation process pre-production. We want to have them go through some testing pre-production, right? And what that means is it means that we're testing the models, means that we're testing the data. The second thing that we want to do is we want to do real-time validation if we can, right? So now that the models are in production, if we have a validation engine, we can create an AI firewall. We can wrap our models with an AI firewall that's going to validate the responses in real time, right, to avoid harmful output. And then the last part is post-production validation. So once we have the responses, right, from either the LLM or just the AI model, right, we can process them on a continual basis, right, and basically run a kind of a post-production validation process to sort of see if there are any issues that we're identifying or any kind of systemic issues that we're identifying over time. So when enterprises are creating their kind of risk management frameworks, they typically use things like now the NIST AI risk management framework, the UI AI Act, the White House Bill of Rights, AI Bill of Rights, and Minder's Atlas framework, right? So roughly any enterprise that you'll see is following those four, typically somewhere between 1 to 4 of these guidelines, right, into sort of creating their risk management framework. When you're thinking about AI risk and you're thinking what should your internal framework include, it should really come down to 4 basic pieces that you should have in your risk framework. The first thing is you need to be able to identify risks and vulnerabilities of the models, right? And that means the validation, the testing that we talked about. The second thing is you need to be able to effectively communicate or manage risk. So it means that basically what it means is it means alerting, notifications, resolving issues. The third one is you want to offer controls for mitigating those risks. And this is like things like AI firewall or giving users an option to select a different model. And then the fourth thing is you want to make reporting easy, either by giving model cards or making models kind of like audit ready. So I'll go through a couple of case studies, and then I'll talk about the DALLE risk assessment that we did, and then we'll leave hopefully somewhere between 5 to 7 minutes for questions. Okay. So first case study of an organization that's managing risk is this is a very large financial institution, and their problem is that they started using third-party models. So you can think of things like Hugging Face and these types of repositories, right? And for that organization, using third-party models exposes a huge deal of risk. We don't know where these models are coming from. We don't know what's inside them. The risks include file vulnerabilities, executable code that can be inside pickle file or PyTorch files, PII data, model weights, and things like that. Right? So the policy that the organization created is that every model and every model and data set that is consumed that comes from a third-party repository should go through some kind of like scanning process. Right? And the control is basically to do model and data validation like on the file level before these go into the main kind of ML pipeline. So the controls there are, these are the risks, and the controls are basically doing this pre-production validation of models at the model and file level. Second example is a huge e-commerce conglomerate, and there are cases that they want to use LLMs and an e-commerce chatbot. Okay. The biggest issues that they're worried about is they're worried about the LLM hallucinating about prices, URLs, things of that nature, right? So what they decided to do as a policy is to deploy the LLM by using some kind of like guardrail framework. And the control that they're choosing to use is AI Firewall. So the risks are, they're largely operational. They're in the kind of category of using real-time validation. They want to have it so that the model does not hallucinate on prices, does not hallucinate on, in URLs. Okay, so generally speaking, something that we can do is we can basically do risk assessments for models. So something that we started doing in the company is we basically started taking a lot of open source models that, that are out there, and then also models for our customers, right? And run them through our product that does automated risk analysis, and basically identify, potential risks in open source models. We also did that for DALL-E. So I got this today, so I'll put this here. Okay. So for DALL-E, I think when we saw DALL-E, back in April, which is like 2 months ago, which I guess in generative AI terms is like, light years ago, ago, right? It was just a kind of an amazing thing, right? Because here you see an open source model that is trained relatively cheaply, right? That can just do, basically perform at such a high level, right? Doing kind of like this instruction following, right? And I think to me, it felt like kind of what I call like it's kind of like a 4-minute mile, right? It's sort of this, kind of like they did what I think is what people thought was impossible to do, like to sort of train models at that level, with open source code, in a way that's relatively cheaply and gets such high performance, right? And I think once we saw DALL-E come out, then we started seeing a kind of a, really a plethora of open source models, right? And we started seeing a lot of people like developing their own LLMs. Right? So because of that, we thought it would be really interesting to sort of see what are the risks of open source models. So we looked at like Falcon and DALL-E and a bunch of other ones, right? And kind of like what are the things that we should be building on top of those, right, to prevent those risks. Okay. So a couple of things. This is by no means exhaustive, but there are just sort of a couple of things that we want to present here. These include operational risks, and ethical risks, and security risks. So some of the operational risks. One that sort of feels like a bit trivial, but it turns out that the model could be very sensitive to capitalization. So when you give it context, in lowercase, then this would be the answer that you get when you're asking what are the examples of organic proteins. But when you change it to be all caps, then the model changes the response. Right. Yeah. So it's like. By the way, there are more things than we'll be discussing here, but you can kind of like read the report if you like. Also, an operational risk, there's sort of some issues with some facts not exactly being correct. So there's some evidence of hallucinations. Like in this case, I think it's assuming that Tesla has the highest revenue in the world. It has unfortunately has serious ethical risks. And it's vulnerable to things like prompt injection. Okay. There are other aspects. There are software supply chain risks. There are other issues in DALL-E. You can find some of these in the reports, and you can, and there are more things that you'll be able to see when you're investigating these. Okay? This is by no means something that's unique to, to DALL-E. These risks are, you can find them in, we're finding them in all the open source models, that we're looking at. We're finding them in non-open source models. So, the risks are, there are risks, using LLMs. I think this is something that we all know. And what that means is it means that we need to test for those risks. We need to validate, the models. We need to be aware of them. And wherever possible, we need to use appropriate controls. We need to use things like AI firewalls. We need to basically identify, kind of models that, that maybe are less risky. And we need to be really thoughtful about the way that we're using LLMs in applications and thinking like who's exposed to these LLMs and what sort of access we're giving them to the models. All right, so at a very high level, the main takeaways I think that I have are that, there are really kind of like three categories of risk that I think are productive to be thinking about. So there are operational risks, ethical risks, security risks. We know that LLMs introduce additional risk, and that's because users can manipulate models with their prompts, and what we do with the models actually, matters quite a bit, right? So those are the kind of like the biggest things that we need to be aware of. In general, LLMs and data sources are extremely vulnerable to adversarial attacks and manipulation, as we saw from some of the red teaming examples. This is because, LLMs are just so powerful, and when we have things that are, just so powerful, it just means that, there's just, the surface area is very large, and there's a lot of opportunity to basically attack them. And finally, and I hope I was able to convince you some of that, is that testing or validation is a very powerful framework that we can use to basically mitigate some of the risks associated with AI and LLMs in particular, right? So the very simple idea of just testing, even creating like very, very simple tests, but then being able to automate them, run them on a regular basis, that is, really key to mitigating a lot of the risks that we're seeing with AI and LLMs in particular. So with that, I want to thank everyone, for coming, and I'll take some questions.